So I'm Jérémy.
My name is Jan.
So I work for Guerrand, which is the company backing up Calico open source, the CNI. So for this talk, we're going to split it in two. I will talk about Calico and what we offer for companies with Calico Cloud, and Jan.
And then I will take over and I will show how we integrate Calico in Rancher and how we can also complement these two technologies with a container security solution to achieve a holistic approach to Kubernetes security.
So let's start it. So for today, we're going to talk about Calico, enhance zero trust security with Calico, Calico with Rancher, and the vulnerability management. So let's start. So what's Calico? So Calico, you're probably already familiar with it. So Calico is an open source solution. It's a container network interface, CNI, for Kubernetes. As of today, it's probably the most used CNI on the market. We have actually 8 million plus nodes in production or test environment, 1 million plus clusters. It's been pulled 1.4 billions. Actually, my colleague checked this morning, it was 1.5 billions image pulled. And 50,000 plus enterprises are using it. 50% of the Fortune 100 in 166 countries. So it's a product that is used massively for Kubernetes in multiple environments, in the cloud, on-prem with Rancher. So we're going to talk about it. So we're going to talk about Calico Cloud, which is a professional enterprise offering built on Calico open source. So we know Calico open source is used widely and it offers a lot of, in terms of networking and security. But we also offer a solution that is more user-friendly with the web UI. And it's something you can use for your daily job, like creating policies, making very easy for you to see the transaction, the flows between the pods. Because at the moment, the challenge in Kubernetes is to know exactly who's talking to who, what's going on, how to secure everything. So we're going to talk a little bit of Calico open source. It's a pluggable data plane. So basically, you can use it with eBPF, Linux IP tables, Windows, and now we are also supporting VPP. So it's a beta feature right now. So it's very flexible. You can basically use it on almost any platform. In terms of performance, best-in-class performance, we have customers with thousands of nodes and they're using Calico. It's highly scalable. You can do all your production on it. People are very satisfied with that. And in terms of CPU usage, etc., the footprint, it's quite low. So then we have other aspect of the product, workload interoperability. So that's also a strength for Calico, is we can use it, on Rancher on-prem, but you can also use it in cloud, so you can have hybrid environment. It works everywhere, and you can mix your workload as well with Windows. That's something also people are liking about Calico, just the way you can use it a bit everywhere. Scalability, encryption, I was talking a little bit of that. So encryption, very useful when security is very critical for you. We can do a WireGuard encryption between nodes. So we think that the encryption within the cluster is probably not that critical if it's on the same node, because everything is inside the node. But when a pod has to talk to another pod on another node, then you're going to go maybe in an external network area. And it's where WireGuard is very powerful for you. You can encrypt the node-to-node connections. Kubernetes native security policy model. That's Calico policies work exactly the same way as the Kubernetes policies. So it's a YAML file, it has the same metadata, namespaces, the rules. It's very straightforward for you to use them. And they can also work with native Kubernetes policies. And also something very important to mention is if you have a Rancher cluster or AKS, EKS, different version of Kubernetes, the policies are exactly the same. So it means you can put them into a pipeline, and then you can push them on all your hybrid environment. So you don't have to read, translate, or modify all the policies. Everything will be working fine. So you just do the job once, and then you put it everywhere. So that's a bit of the idea of Calico. So now we have security policies. So policy as a code. So basically, a policy is like a YAML file, and you just code the rules, a bit like a firewall policy. You know, we're going to use metadata like namespace, labels, and then we're going to, add some rules like open TCP something, or don't talk to this namespace. And it will create this kind of micro segmentations and isolations of your workloads. That's how we are going to build that. So if you use Calico Cloud, we have the web UI. So you won't have to know the code by heart, and it's prone to mistake. So we'll have like a web UI where you can create policies, and we also have a policy recommendations. Okay. There is also something we have added to the product is called the policy tiers. So the idea right now in Kubernetes is the policies work by order. So you read the first one and then the next one and so on. And it's all in the same recipient. So we have created the policy tiers. Basically, we can segment the policies in different recipients, and each tier will have its own RBAC roles and permissions. So you can let people, like the developers, having the right to create policies inside a product tier, like for the, the production or the application. And then you can have a platform tier and a security tier. So the idea is just to avoid friction between teams, because if you're a developer and you have to open maybe a flow between two pods or two microservices, you'll have to open a ticket, and then you'll have to get the change accepted, then you do the change in a test environment, and so on, and so on, and it will take maybe like a week or two. If you have the right to change policies in one specific tier, you won't affect, the north-south control, but you will just, affect your application. So the developers, they'll be able, to move very, very quick for their policy changes. And then we have other features, like the egress gateway. So that's also a very big concern. Is nowadays, nothing is Kubernetes. It's pure Kubernetes. We have to do a transition from the old infrastructure to the new one. And it's not only the infrastructure in terms of hardware, software, it's also the people skills. And some teams right now, like the security team, they don't really want to go on Kubernetes right now. But the infrastructure team, they have to move on Kubernetes. So it creates this kind of frictions between the teams where you want the security team to maybe create policies for north-south control. But the problem is the pods, they are ephemeral, they don't exist for long, and they scale up, down. So working with IP, static IP is kind of not possible. So what we've done with the egress gateway is on the cluster you'll have pods that will have a fixed IP that will be known by the firewall. And your applications, so it could be a pod, a label, a namespace, will be forced to use the egress gateway to exit. So it means you can say application A, B, C will use egress gateway X. So it means now your security team for the perimeter will be able to create policies in the firewall to control that. Instead of opening a wider CIDR, you'll be able to just maybe open a few IPs like /30 and something. Second challenge for the companies is the DNS policies. You cannot really say, I want to block google.com or something. So you have to use IPs. It can be very problematic because it's kind of a manual labor and it's not really dynamic. So we have introduced DNS policies. If you have to talk to Salesforce, api.google.com or something, you can simply now create a policy to authorize or deny that. another aspect of the policies, we have added network set and also global policies. So network set, it's very interesting because maybe you have a thread feed from a third-party security vendor that will give you a link, a URL with some malicious IPs of the day. We can create a network set that will use that thread feed to create something dynamic. And then you're going to create a policy based on that network set. And the idea is every day you'll have an update, a new IP will be added to the network set, and your policy will always be using that feed. So your pods will never be, talking to something malicious. And the global policies are speaking to themselves, instead of having a policy for a namespace, you can do a global policy for the whole cluster. And it could be workload and non-workload. So you can create policies for hosts and pods as well. So identity-aware microsegmentations, dynamic segmentations, upload segmentations, policies in milliseconds. So what does it mean? Like I said earlier, we can create policies for different platforms, hybrid, on-prem, cloud, and so on. So it means you can create one policy in a test environment. It could be kind with the tiny Kubernetes and Calico. It could be egress, it could be Rancher. And then when it's created, you can download your policies in YAML. You can push them into your CI/CD pipe, and then you can put that into your on-prem environment. So you don't have to retranslate everything into another language for the other platform. So that's where the product is kind of good, because you can work in a small environment and then you can deploy everything en masse on your Rancher on-prem environment. In EMEA, for instance, I work in France market, and people love Rancher because they love their VMware environment. But sometimes, they just have some test environment in AKS because it's convenient. You just click start, and that's pretty much it. But then when it comes to production, they go on-prem. And it's where the product is good because they can just download their manifest from the UI and then push them into production. So dynamic segmentation, we work with labels in Kubernetes. So it means when a pod is scaling up and down, we are based on the labels. So it means the policies will always protect your micro applications and microservices. Compliance and encryptions. So that's something very important right now. Security breaches are getting more and more public and popular, and the companies are trying to force and push regulations like GDPR, SOC, PCI, and it's where the companies are asking for some tools to audit and see what's going on in Kubernetes. Right now, if you want to know if you're compliant, you'll have to describe all your pods, check out, the deployment, see the labels, how is it built, etc. Here with Calico Cloud, we'll be able to generate the reports, and you'll see all your inventory. So you can see all the labels, who is able to talk to whom, and then you'll know that you're compliant. Data in transit encryptions, WireGuard, node to node, it's what I was saying earlier. What's happening is when a pod has to talk to another pod on another node, it's going to be encrypted. We didn't choose the MTLS approach with the service mesh, where every pod are encrypted with each other, because it's labor intensive, prone to mistakes, human mistakes, and you're going to multiply all your environment with sidecars. So that's why the WireGuard is the most efficient in terms of resource and protection. It's the best of both worlds, basically. Evidence and audit reports. That's something also we have. We have all the flow logs. Everything is recorded, in the Elastic engine. So it's also mean you can, query all your flow logs, and you can start to see what's going on, basically. So we can do a quick demo of the platform just to show you 5 minutes how it looks like, and then we can go to Rancher. So let me switch to Calico Cloud. So by the way, Calico Cloud is the professional enterprise offering to Calico open source, but we are working on a project where we're going to add a mini Calico Cloud, a free tier, where you can connect your open source to the web, SaaS, and you'll be able to see what I'm going to show you for free. So if you want to try Calico Cloud, we have 14 days trials, so you can just create an account, you add your cluster, it will generate a script, and you can just connect any cluster to Calico Cloud. Okay. So that's Calico Cloud. After I'm showing you how to connect a cluster. So you're going into the manage clusters, and you can connect your cluster like that. It's simple. So Jérémy, test. You choose the kind. So you can use Cube ADM if you're using like Rancher on-prem VMware. And then you select the version of Calico you want, and you connect. It's going to generate a script for you, and you just copy-paste that into your Kubernetes cluster. We can use Calico, but you can also use Azure CNI and AWS VPC CNI. So in that case, my cluster uses Calico open source, and you upgrade the operator, and it's going to connect to the cluster. So it's a SaaS, so you'll have nothing on your environment, so you don't have to care about storage and so on. So what do we have in the free tier? We'll have the policies. So we have the policies board. Much more convenient for you to look at your policies, how many you have, in which tier they are, security platform product. Like I said, you can create users with specific permissions to create or view policies. So your developers may be able to create a policy in product, and maybe a security persona from the perimeter will be focused maybe on the platform of security tier for the north-south control. When you want to see a policy, you can simply click on it, and it will open the YAML into this nice UI, and you can see all the key informations such as namespace, labels, rules, and you can also get the statistics per rule. So if there is something denying, you'll be automatically aware of that, and you can just click on the rule and see what's going on, which rule is blocking, and so on. Let's say you use Calico Cloud as a test environment to practice your policies. You can then download the policy into a YAML. So it's very convenient for you to avoid human mistakes, basically. So we can see the API and the tier, the name of the policy, the namespace, and the rules. Let's say now you can see your policies, what they are doing, what they are blocking, the orders of them. It helps you to build like compliances like PCI, because you can see your PCI policies, the pods or endpoints that are affected by your policy. Like here, you can click on the endpoint. Sorry, I don't know why I read the page. Is it the Wi-Fi? Sorry. Okay, awesome. Are we back? Yeah. And then you'll see the endpoints that are, protected by the policy, and we can now go into the service graph, which is the second part of the product. Service graph is a visualization of your workloads what's going on in your cluster. So we'll be able to, maybe let me zoom it. You'll be able to see all the communications between namespaces, like kubesystem, Acme, an attack namespace, Calico Cloud, and so on. And if you double click into one of your namespaces, you can see what's going on inside. So in that case, I created an attacker pod is pinging everything. And like we see, it's getting denied by the policies. And you can simply click into one of the connection. And on the left, we'll have like a quick overview of protocol ports. And at the bottom, if I click on the namespace or a service, I can see the flow logs. So flow logs are quite straightforward. We'll have source, destination, and all the metadata, such as IP addresses, labels, names, and so on. And that's something you can also export into a Kibana, Splunk, syslog. So you can even give those information to your security people, and they won't have, to work with Kubernetes. They'll have the flow logs for themselves. And that's pretty much what I wanted to show you. So that will be in Calico Cloud free tier. And if you want to try out, there is Calico Cloud with 14-day trials where you can connect your clusters. And with the paid version, we'll have other options such as web application firewall, thread feeds, the security events, alerting, and so on. So thread feeds, it's what I was saying. You can add like a Feodo tracker. And you'll have like a third-party company, security company that provides you IP addresses from the day, like malicious IP addresses. And then you can create network policies using those network sets. So that's pretty much it for Calico. And Jan is preparing the second laptop for NeuVector.
Okay, thank you very much. Let's do a smooth transition.
Almost.
Okay, perfect. Okay, perfect. So thank you very much for the introduction of Calico. Of course, doing traffic management or implementing network policies is very critical to ensuring the security of your applications within a container platform or a Kubernetes cluster, but there's much more to it. Before you, of course, start to using Calico, you need a cluster. One way to manage and provision clusters is by using Rancher. For those of you who don't know Rancher, it's the most popular open source enterprise container management platform. And we use Calico actually when we provision clusters. So we are able to provision clusters in any infrastructure in the cloud or in on-premise or on the edge. And Calico is actually our default CNI plugin. We have a few other options for specific purposes, but Calico is very battle-tested CNI plugin, which we install by default. To make it really easy for you, Rancher manages also the lifecycle of Calico. So that means whenever you patch your Kubernetes cluster, we also give you not only a new Kubernetes version, but we also give you a new Calico version. And obviously, we also make sure that we also validate and test Calico against this Kubernetes version to make sure that everything is working smoothly. Calico is typically deployed using an operator. And when provisioning clusters with Rancher, we provide you access to all the parameters of that operator to allow you to tweak things and configure Calico in the way that you need it. Since we're talking about security today, let's bring another piece of software into the mix, which is called NeuVector. NeuVector is also an open source technology, and it can be very neatly integrated together with Rancher and also together with Calico and Calico network policies. NeuVector is a container security solution, so it is deployed in the cluster itself, just like Calico as well. So it's not running somewhere in the cloud or externally, it's always deployed in the cluster. And we actually have a two-tiered or two-prong approach to security in NeuVector. One of those tiers is the supply chain security. This is your typical CVE vulnerability scanning, but across the entire supply chain. And the other focus that we have in NeuVector is runtime security. So as always in security, you need multiple layers until you really reach a high level of security. And this is exactly what we're doing. So we're doing the basic stuff like scanning for CVEs and implementing admission policies. And then we take this to the next level and do also runtime security to cover the other bits. So let's have a closer look at supply chain. With the supply chain security, what you're basically doing is you implement the shift security left paradigm. That means that it is part of your developers to also take care of security, and this is exactly what we can do with NeuVector as well. So typically, the supply chain starts either with your own developers, or maybe you have a third-party software provider who gives you their container image. But let's just start with the case where your own developers are working on an application. So typically, the developer is writing some code, and at some point, he's probably committing that code to a source code management system, like a Git server. And typically, there's also some kind of CI or even CI/CD system that just gets triggered based on the commit that the developer is doing. This is the first step where you can already integrate image scanning with NeuVector. And basically, NeuVector at this point can check the code and the image from the developer to see if there's any known vulnerabilities in there. And it can also compare it against some best practice policies. And depending on the result of that check, you can either fail the build, or you can, for example, block the merge of the pull request and things like that. And then force the developer to fix it and update his pull request. At some point, the build completes, the commit is merged, and there's a new release cut, and then the image is probably pushed into a container registry. And this is the next point where you should also do image scanning. And with NeuVector, actually, you do this continuously, because obviously every day there are new CVEs, new vulnerabilities that are published. And an image that might previously passed all the checks with flying colors might now have a critical CVE. So you need to continuously checking your images. The same is true if you get your software from a third-party provider and you then upload these images to your container registry. You want to also make sure that they are free from any known vulnerabilities at this point. And then at some point, you want to obviously deploy that application. You want to deploy that container. And here comes a very critical piece of software, which is the admission control. So the admission control in Kubernetes is basically like a doorkeeper. It allows you or a third-party software to inspect every API call or every change that is done to the Kubernetes cluster and compare it to some kind of policy. So it's quite flexible in that way. You can use this to implement many interesting patterns and things. But what we use this for in NeuVector is basically vulnerability management. That means after scanning, you have some results. Now you know that this image has these vulnerabilities and maybe these scores and criticalities. But part of the vulnerability management is then to say, what do I do based on these results? Because probably you don't want to just completely deny any image that maybe has a low severity CVE to be running, right? So you want to set up some policies. For example, you want to say, if an image has one critical vulnerability, it's not allowed in the cluster. Or maybe you want to say that I only deny the image if there's a fix available. And for those applications where there's no patch available, I allow it to run maybe for 2 more weeks. So it's very powerful and flexible in the way that you can then implement this vulnerability management there. So image scanning is important. It's just you have to do it. There's no way around it. You don't want to introduce insecure software into your container platform. So yeah, you have to do it, but it's also not enough. So not all attacks are based on exploiting a known CVE. So there's zero-day exploits. So that means vulnerabilities that have not been published or have not been found. There could also be a vulnerability in your own application. So not in a third-party library for which we have a CVE database, but the vulnerability could be in your own application. Or maybe the attack is not based on a vulnerability, but maybe some leaked credentials, and someone is accessing your cluster and maybe stealing data from it. So there's a lot of other attacks that you need to be prepared to cover and have a defense against it. And image scanning will not help with it. So you need some more stuff in there. And here comes in the runtime security scanning that we provide with NeuVector. And again, here we can divide this into 2 different sets of defense mechanisms. So one set is based on basically signatures of attacks. So that could be the OWASP threats, or that could be based on detecting that there's credit card numbers in some payload that is currently transferred to the internet and things like that. So these are all signature-based defense mechanisms. But they also are not complete because they're based on signatures, so it must be a known attack vector that is being used, and that will not always protect you. So the other thing that we do is what we call zero trust controls. And basically what zero trust means is that we acknowledge that we do not know all the possible attacks. So what we do instead is we implement zero trust, and that means that any behavior of an application that is unexpected, that is abnormal, is a potential threat, and it will at least trigger an alert, or even it will maybe trigger a block and quarantine that container. And obviously, what this requires is that you create a baseline of the expected behavior of a container. Behavior in terms of what network connections does the container open, what files are open in the container, what processes are running. And this normally is an impossible task. So no one wants to do this for every container to basically write down the behavior. So what we do instead is we implement a learning mechanism. So that means that when you run your container for the first time, potentially in a staging environment or in a testing environment, NeuVector will automatically learn the behavior. And based on that learned behavior, it will then create a set of rules. Which ports is the container talking to, which files open, which processes open, and so on, and so on. And this allows you then to have this baseline of allowed behavior, and then you can deploy this container in your production environment, and any behavior that NeuVector finds that deviates from that set of policies will trigger an alert or even a quarantine of the container. These rules, by the way, can also be managed in security as code approach. So you can export them in YAML manifests. You can check them into a source code repository. And you can even modify them and then deploy them together with the application into your production environment. One of the challenges for security in Kubernetes is the networking. So typically, Kubernetes Kubernetes CNIs uses overlay networks. And what's going on in this overlay network is not really transparent to the traditional network monitoring in your IT infrastructure. So that is a challenge. So obviously, one approach is using a CNI such as Calico, which gives you visibility of what is going on. And another approach is using a container security solution, such as NeuVector, that is able to inspect that traffic and also analyze it. So if you look at a typical cluster, the traffic that is going on here is obviously a lot of east-west traffic, so containers speaking to other containers. NeuVector can understand this traffic. It can analyze it on several layers, including the application layer. And the other traffic, obviously, is the north-south traffic. So in Kubernetes, that's typically via the ingress or outgoing connections from your containers to some targets outside of the cluster. With NeuVector, we are able to understand the complete traffic of the containers. That also includes containers who use a service mesh. So we can even understand what kind of protocols the containers are talking there. So at this point, I also want to switch to a quick demo to give you just a little bit of a better understanding. So let's just start with Rancher. So this is oh, sorry, why don't I see that? I think I probably have to stop the demo presentation. Okay, perfect. So let's start with showing just quickly the integration of Calico and Rancher. So Rancher, let's say I just want to have a new Kubernetes cluster, maybe in a custom infrastructure. And you can see here, I can choose next to the Kubernetes version that I would like to run. I can also choose the network CNI plugin, and in this case, Calico. I can also set some other network-related things, like, for example, I can isolate different namespaces and projects by default on the network layer. So that's particularly interesting if you have a multi-tenant cluster that is shared by several teams or applications. And every time I do a change and patch this cluster version, I automatically get also the new Calico version. So now let's quickly talk also about NeuVector and to see it in action. So NeuVector, as I said before, is deployed together with your application in your cluster. And let's just have a look how this looks like. In Rancher, you have a set of additional applications that you can launch in a cluster, ranging from some block storage solution to monitoring. And one of these additional technologies is also NeuVector. So it's very easy to just start it. And once you have installed in the cluster, it's available at the point of your hands. In this cluster here, I have already deployed some application under the workloads. So let's see if I can show it to you here. So that's just basically a simple, a microservice application. And I intentionally used some outdated images, so we have some nice vulnerabilities to look at. And next, I'm going to start the NeuVector UI. So there's a direct link from here. And this opens the dashboard, or not exactly, so let's go to the dashboard. And the dashboard gives me a high-level overview of the security state of the cluster. So you see the scoring is fair. That's because I have a lot of CVEs in the images. And it also shows me like some potential security risks of applications exposed via an ingress and different things like that. NeuVector does not only scan the containers, it really scans the complete platform. So let's have a look at the assets that we are scanning. So it starts obviously with Kubernetes itself, because Kubernetes also in the past has had some CVEs. So you want to make sure that you're running a secure version, patched version of Kubernetes. At the moment, I'm using a fairly recent patch version, so I don't have any CVEs here at the moment. The other thing that we are scanning are the nodes themselves. So not the containers, but the actual host operating systems. And we scan them for any violations of compliance, but obviously also for CVEs. So for example, here you get the list of all the CVEs we found in the libraries on our nodes. And for each CVE, you can see if there's a patch available, what the scoring is, and you can also open it to look at the database to find out some more information about it. Then obviously we get an overview of the complete containers that are running in this cluster. Now let's maybe filter for our shop front end. And let's see, where don't I see any results here? Okay, so yeah. So we can see we already have some scan results here of the processes that are running, but I actually wanted to look at the vulnerabilities. So let's, here they are, okay. So here we can see the vulnerabilities in the container images, and the same way, so we get information, oh, there's actually a fix available, so this could easily be patched by the developers. And we also have some compliance checks, so let's look at some other container here. Where I know that there's a compliance issue. Yeah, so this way, so you can see we have checked this against the best practices for containers. I think this is from the CIS, Center of Internet Security. They have kind of like a guideline for container security, and we can see here that they recommend us to change the security bit, the file permission bit on this file, because it's potentially insecure. Then, of course, we also can use this NeuVector instance to scan the images that are not on the cluster, but on the registries. We can add additional registries. This could be private registries or Docker Hub or some other registry. In this example, we can see we get the results of these image scans, and we can even open this up to get some more detailed view into the image. And what's really nice is that NeuVector also scans the different layers of the images. And this really helps, for example, if you suddenly have a CVE and you want to find out where in the Docker file or with which command that CVE landed in the image. And you can just navigate to the layer, and you can see in this case, it was actually copied, a binary was copied into the image. And this is the binary that contains the CVE. So let's have a look at the zero trust and runtime security that I was talking on before about. So in the groups settings, you have all the applications running currently in the cluster. And again, we can filter here a little bit. And the first thing you see is for each container application, you can have 3 different modes. Protection modes. At the moment, you can see this is in the learning mode, discover mode, or learning mode. And in this mode, basically the behavior is learned, and new rules and policies are created based on the learned behavior. At the moment, this is completed, so there's nothing new happening in this container. And we can see that NeuVector automatically created some roles. So let's see. See this again. Yeah, okay. So here, for example, NeuVector has learned all the processes that have been or are running at any given moment in the container. And obviously, it makes always sense to also review this by the application owner, by the development team, to make sure if this makes any sense. Maybe you find some early issues here even. And then we also have the same for the networking. So we understand all the communication source and target. So this is a microservice, so there's a lot of other communication targets. But we can see that everything is basically internally. We are not talking to the internet or anything like that. So let's see how we can learn new behavior and automatically create a policy on that. So let's go back to the file. And now let's go to our application in the Rancher UI. And let's find the pod that we want to check this out. So that's the front end pod. And we can open now a shell in this, and we can run some commands. So let's see, let's run just a wget, and Let's see, when we go back here, refresh, did I run it in the wrong container? So make sure that we are in the right container here. Online front end. Yeah, it was maybe not the right one, okay. And now let's refresh. And you can see, so now we have learned a new policy. And because we are still in learning mode, we allow the policies to be updated. Now let's switch to another mode here. So now we have two other available modes that we can use. One is the monitor mode and one is the protect mode. I think it's fairly clear what the difference is. So in the monitor mode, we detect any anomalies, but we don't do anything about it other than creating an alert. And in the protect mode, we basically don't allow, we block that behavior. So in the case of a networking connection, we block the networking connection. In the case of a new process, we don't allow the process to be spawned in the first place. So let's just switch this to monitor mode. And obviously, we also want to remove. That rule. And let's go back to our shell and run the wget again, which still works. But now, when we go to our security events, we can see that we got an alert here, that there was an anomaly detected, and that this command should not be allowed. And yeah, but at the moment we are in monitoring mode, so we just got an alert. So now let's switch this up a notch. Go back to our policies. Oops. And switch now into our protect mode. And now let's try the same again. And you can see now the process didn't even start, so we did not even allow the wget process to be spawned. And also here we get, of course, notifications about the security event. And we could also review it and say, oh, this is a false positive, right? And we could quickly create an exception for that, just to make sure that this false positive doesn't interfere with our application. So at this point, I just want to point out again that the technologies that we presented today, Calico, Rancher, but also NeuVector, they are all open source. So it's very easy to get started yourself and try it out. You can head out to GitHub to look at the source code and just get started. So back to you. You want to say some final words? No, not yet.
Hello.
Yeah.
No, I think it's pretty self-explanatory. So yeah, Project Calico is the open source project, so you can use it everywhere you want. And if at some stage you want to try, the web UI to see all your flow logs and all your communications within the cluster, you can just go to Calico Cloud and just connect your cluster to it, and you'll have 2 weeks of free trial. And like I said, later in few releases, there will be a lightweight version that could be offer free to you.
Yeah, maybe my final words would be, we have just shown a subset of the capabilities in NeuVector. We haven't looked at the admission control, which is a quite powerful feature, or things like a WAF that is also integrated in NeuVector. So that's really something, if you're interested in this kind of security tools, something for you to explore. And with this, I would say our talk is completed. But if there's any questions, we are happy to answer them.
Thank you. Something.
Thank you.
So are there any questions?
No.
You guys are all tired? Yes. Yes, a question.
Perfect. Yeah, one question.
One question. How does NeuVector is able to interfere with the processes in the containers? So you said this allows to spawn this wget process. How does this work on the technical level?
Basically in the kernel level. So we interrupt the syscall to spawn the new process. So it's all working at the kernel level. And this is also how NeuVector understands all the traffic that happens on that host. Yeah. So it's a kernel function.
Okay, so how does it get into the kernel of my image?
Well, the kernel, there's only one
it's
kernel
not the
running
image.
on the node.
Yeah.
The container itself does not have a running kernel instance. And NeuVector does this with well-published kernel interfaces. So one is for the traffic. I think we use a kernel interface that's called TC, which allows us to hook into all the traffic. And there's different other things. We also use some eBGP. Did I say that correctly?
Yeah, BGP.
Yeah.
Maybe eBPF.
For some features, but not for all of them, because for performance reasons. But yeah, so that's the way how we do it. No sidecar. It's not using sidecar. Maybe that was a thought. We're not using sidecars.
Okay, thank you.
Anything else? Anyone else want to say something? Ask something? All right, then that's a wrap. Thank you, guys.
Thank you. Thank you everyone for joining us.